Watch next for SystemVerilog in the upcoming IEEE 1800 standard. That's right. The last version of the SystemVerilog LLM was completed in 2016 and published IEEE 1800-2017. And the time since, the tool vendors have continued to extend the making the clarifying the changes to their implementation. That leaves users and other tool vendors with unclear specifications on how to interpret the SystemVerilog code. The next revision of the standard P1800-2023 intended to address many of these issues to keep the language current. This paper reviews some of the high-level goals for the next revision, as well as highlights a few key enhancements. Introduction. Between the Authority Systems Initiative and the IEEE, there have been 7 revisions of the SystemVerilog Language Reference Manual (LRM) over the past 20 years. The 5 of those revisions were in the first 10 years. So many users avoid adopting the SystemVerilog because features support from different tools and vendors of rapidly changing LRM had been so inconsistent. To this day, people continue using Verilog 1995 syntax and avoid using features added by Verilog 2001, for example, ANSI style purge and the power operator. So brakes were put on the SystemVerilog LLM process, giving a vendor the chance to catch up and giving users the stability they wanted. The last meeting of the IEEE SystemVerilog Technical Committee met to add changes to the LLM was at the end of 2016. The result of this work was the publication of the IEEE 1800-2017 standard. However, technology never stands still. So over the last several years, vendors have made the extension to their tools based on the demands from customers, and the users are left with a hodgepodge of the features with no or incomplete documentation. For example, some tools allow many more built-in functions like $s format tf to be used in a constant expression even though the LRM explicitly does not allow it. You won't know which one your tools support until you try them. Other users simply won't wait for any extension and begin working around language's limitation by creating extra code packages or incorporating other languages into their flow, C#, Perl, Python, Ruby. Don't expect the SystemVerilog to be the number of languages choice for every design and verification project out there. Still, every language must evolve to be improved and stay relevant, and the developers want to protect their investment in verification IP they develop for as long as possible. So under the auspices of the IEEE, a project P1800 to craft the next revision of the SystemVerilog was created in the late 2019. P is a proposed standard, and the current plan is to finalize it to work and make it available to the public in 2024. After 2 years delay due to the worldwide pandemic, so a working group made of the end users and 2 vendor companies formed to submit the issues to behalf of themselves or indirectly through the affiliated the companies. This IEEE working group uses an issue tracking system called Mantis. The group enters issues into Mantis database that are categorized into few major types. Enhancement. New features that extended the capability of the current language. This enhancement may already be implemented in some tools or be completed in user language. In many cases, they have been borrowed from other languages, though their use models are well known. Errata, obvious mistake in the current LLM. They could be as small as typographical editing errors or as large as contradiction in the text between the LRM sections because the previous update failed to capture all places that needed to be changed. Sometimes the current wording of the LRM is obviously incorrect and tools have implemented what the LRM should have said in the first place. Clarifications. Missing or misleading text for a particular use case where the LRM is ambiguous. This number does not involve changing to a tool's behavior unless tools implemented something very different from what was originally intended. As of the publication data of this paper, 26 enhancement and 109 errata and 61 classification have been approved by the committee for the next revision of the standard. These categories are not always distinct. Many enhancements uncover the existing errata issues or require other classification. Sometimes an issue filed as an enhancement becomes just clarification. These sections that follow highlight just a few significant issues from each categories. Chapter 2 Enhancement A. Extending cover point Mantis is 4703. One of the most often requested enhancements and my primary motivation for getting this project started is extending cover groups. Cover groups without inheritance is considered by many an unfinished feature. When extending a class, you can add new class members and override existing ones in the base class. The same holds true for constraint in classes. When embedding the cover groups in classes, they are effectively additional class members. It seems obvious that a simple principle should have been applied to the cover groups. This comes up frequently when creating verification IP-based class libraries, and these libraries need to be extended to handle customization for different usage configurations. Two of the most critical features enabled by this enhancement are adding a new cover group in an extended class and then crossing in an existing cover point in the base class. Currently, you must replicate the cover point in the base class to extend the class and cross it with a new cover point, replacing bean structure of the existing cover point or removing it entirely. The enhancement would allow the syntax such as here the point is the cover point B from the base class is changed. So the level comes from the base class. B. Unpack array mapping function Mantis 7610. SystemVerilog allows you to work with arrays aggregated as a whole. However, it limits you to comparison and assigned operators as well as working only the unpacked arrays having equivalent element type. Borrowing from the other languages such as Python, the array map function allows you to cast each element to a new type as well as perform any operation on each element. Like the manipulation method, see section 7.1204. The map method iterates over each element using the with method expression and will provide not method with expression and provide implicit variables item.index. It returns a new array with each element having the type of that expression. Here are a few examples. Then C. The if-defined Boolean combination of identifier Mantis 1084. This request preceded the publication of first SystemVerilog LLM. Enhancements related to the preprocessor have been very difficult to address because of many ambiguities in this area of the existing LLM. See Mantis 1014 in the clarification section. Verilog has a simple if-define scheme where you specify a single macro name to testify it is defined or not. There is no way to combine testing multiple definition with nesting multiple if depths or created intermediate defined macros, assuming that the two potential macro definition A and B. In the existing Verilog LLM, you would have to write with this enhancement, you can use a simple Boolean expression enclosed in parentheses. Note that the value of the definition is not being tested, so only the state of each definition in C or C++, and this would be equivalent like this. D. Add support for multi-line string, Mantis 7308. The basic premise of this request is allowing multi-line and quoted string within a string literal. This feature makes it easier to write informative or self-documenting messages so they can be easily read and maintained within the source code. The enhancement request seems to be simple on the surface and are entangled with many other issues surrounding multi-line string letters in a text macro, Mantis 1397, and special characters in string, Mantis 1507, printable characters, Mantis 7562. E. Real number modeling, Mantis 7295 and 7669. SystemVerilog formed around the concept of being a digital logic design and verification language. That means that most constructs and operators expect expression to break down into discrete integral or the Boolean values. Constraint assertions and cover groups rely heavily on equality expressions. Real numbers introduce irregularities with expression like 1.0 plus 1.2 equals 0.3. Can never evaluate true because these floating point values cannot be accurately represented in a binary number system. So adding real numbers to random variables and constraints involves lifting the existing restriction from integral to allow for real types. Distribution of the floating point ranges can only deal with weight over the entire range using the 1.0 colon 2 3.0 2 slash divide weight, and makes no sense to allow the other distribution colon equals syntax which would have applied to the weight to every value in the range. There are an infinite number of discrete values in the range between the two real numbers, thus the weight of the range would be infinite. Adding real numbers to cover group requires a little more consideration. Coverage beings by their nature represent discrete sets of values. A new option real underscore interval helps break up the floating point ranges into non-overlapping being sets. Coverpoints are F. Changing of the method called Mantis 2735. This allows you to use the result of the function to serve an intermediate value for selecting a member of the result. It is mainly used when the result is handed to a class, so it may come as a surprise that it was not already included in the LLM, as many tools have been supporting some form of it for a while. Now it is properly defined. One of the major issues with this feature is keeping backward compatibility with Verilog. It allows a hierarchical reference to static variables declared inside a function from outside that function. To distinguish a hierarchical reference from an intermediate variable, you must use parentheses and the function call even when there are no arguments. The first direct display statement prints the value of the hierarchical reference to the static variable top.f.member, whose value is 0. The second $display statement calls the function f, whose returned value gets used to select the class A variable members whose value is 1 and 23. So G, adding static reference argument Mantis 2583. A left argument of time-consuming task tracks values updating between the actual argument passed into a task and former argument defined inside the task during the lifetime is called. In contrast, the actual input argument passes its value only the point in time when the task gets called. The implementing a reference argument places more restriction than passing an argument value because the code inside the task has no knowledge of the actual argument declaration. One restriction is the former argument types must match. It's not enough just to be assigned compatible. Another restriction is the task must assume that actual argument lifetime is automatic. The consequence of them means that there are several other restrictions on what you cannot do with the variables declared with the automatic lifetimes. An argument passed by the reference cannot be the target of the non-blocking assignment, have reference LHS or RHS force of the for statement. Be referenced from within the fork join any join known process. This enhancement adds the static qualifier to format left argument to the task or function can be assured that the actual argument has a static lifetime. It would be an error to pass an variable with an automatic lifetime as an actual argument. 3. Errata. A. The clocking block name is unequal to its associated clocking event Mantis 7172. The current LLM has this brief example in section 14.14.10 clocking block events. So the clocking event of the DRAM clocking block can be used to wait for the particular event. The preceding statement is equivalent to the passage P1800-2023. However, this cannot be true since section 14.13 said the DRAM event gets triggered in the observed region in the passage FHI1 gets triggered in the active region. So the example was expanded with a more dedicated detailed explanation. Always at passage FI1 display clocking event, always at DRAM display the clocking block event. The first always procedure and the preceding example execute in the same active or reactive event region as the positive edge of the FHI1. In contrast, the second always procedure executed after the observed region following the active or reactive event region. This behavior can be used to avoid race condition when sampling input data. See 14.14.13 for more details. B. Non-integral function actual the argument allowed in a constraint expression Mantis 2841. The current LLM said this about constraint section 18.3. The constraint can be any SystemVerilog expression with variables and a constant of the integral type. For example, bit, rag, logic, integer, enumeration, pack to struct. Section 18.18.5.13 constraint guard already contradiction this with object handlers, but there are many scenarios where there is not a problem using non-random, non-integral expression. For example, a real-time threshold variables require the user to create and initialize a separate integral variables. Only this can be used in the constraint. Mantis 2841 allowed the above to be written as. So the 4 classification. A. Unclear which compiler directives must be alone on linear. Mantis 1014. Like Mantis 1084, this is a clarification request carried over from the Verilog 1364 standardization effort. Compiler directives have always having a weak point and considered underspecified in the LLM. Under enhancement request for multi-line string brought the priority of this issue to be the forefront. One of the most common places that this comes up is with a conditional compilation. Suppose for the structure or directives was unclear and the existing RM and has been clarified. Most tools have already been supporting this. The B. Definition of the term blocking statement Mantis 2 and 25. One of the oldest issues to be clarified. The term blocking is well understood by experienced users but was never properly defined. This is particularly a problem because the word block is a homonym with multiple unrelated meanings. Within this standard, a block could be used as a noun to describe a set of connected conceptual elements or as a verb, a construct that suspended execution of a process. The term blocking statement in most cases refers to a construct having the potential to suspend the process. But this is further complicated using terms non-blocking assignment, which is never a blocking statement, and a blocking statement assignment, which is only sometimes a blocking statement. The three terms, blocking statement, non-blocking statement, and a blocking assignment, blocking statement, non-blocking assignment, and blocking assignment have been clarified in the upcoming standard. It is shown in by the illustrative examples below. The C. Packed array shortcut Mantis 3 and 25. This issue originally started out as an enhancement request. Verilog declares array ranges with pairs of index values. For packed arrays of integral factor, the left index value represents the most significant B MSB, and the right index is the least significant LSB. Integral factors are normally declared using an LSB 0-bit numbering scheme when the index of the LSB is 0 or little bit endian. And the index of MSB is the width of the vector minus 1. Thus, the bit index position I represents the ith power values of the vector. So, unpacked arrays are also declared with pairs of index values. However, since most references to unpacked arrays only select one element at a time, or select the entire array as a whole, element zero's positions is not as important. It does matter when loading the array from the external file or streaming to another array with a different index ordering. SystemVerilog has a shortcut for declaring the unpacked arrays range with a single numbers as in C or C++. The following two declarations are equivalent. Note that int is a shortcut of a bit assigned 32 to 0, with the index 0 bit being in the LSB. Therefore, There are also several implicit pact declarations that use the index 0 for the LSB numbering, pact structure, and unions and concatenation expression part selects. This enhancement request asks for the same shortcut syntax for declaring pact arrays with a single number. For example, B0, V, and 8, AB, hexa AB, propose shorthanded for bit 0 to 70, and V, A, quad hexa HB. But there was uncertainty as to whether the shortcut should be little bit endian to match packed arrays or a bit endian to match little bit endian and big bit and big bit endian to match the index ordering of the unpacked array shortcut. In the end, the committee decided the potential confusion this enhancement would create was not justified, and in fact the LRM now provides further clarity stating the array declaration shortcut only applies to the unpacked arrays. 4. Summary. This paper has presented in just a few of the many changes in upcoming IEEE SystemVerilog standard. I have pointed out the process of the working group goes through to address each individual issue. Many issues the group goes through and not discussed here require no changes because they were found to be already addressed by other issues unnecessary because they were easily covered by other features or out of scope for the current updated standard proposal. Note that the P1800-2023 is not a formally approved IEEE standard. All the features mentioned here are subject to final IEEE balloting approval. Reference like this. And today I read this paper. Watch next for SystemVerilog in the upcoming IEEE 1800 standard from DVCON 2024. Thank you for your time. See you next time.